Assalamualaikum and a very good day. We are from Group 4 and we will presenting about thermodynamics and heat transfer. My name is Hari Izzuddin bin Rosdi and my metric number is B0819100057.
Assalamualaikum. My name is Ahmad Ashraf bin Ahmad and my matric number is B0819103330.
Hello, my name is Muhammad Aswad bin Alwi. My metric number is B08191023.
Assalamualaikum. My name is Azrain Nazrin bin Azali. My matric number is B0819102001.
Okay, hello. So my name is Muhammad Akmal Arif bin Muhammad Adam. My matric number is B0819100069.
Assalamualaikum warahmatullahi wabarakatuh. So today we will present for subject thermodynamic and heat. Our topic is refrigerator and this is our group member from group 4. For introduction, a refrigerator is a device which is designed to remove heat from a space that is at lower temperature that is surrounding. The same device can be used to heat a volume that is at higher temperature than the surrounding. In this case, the device is called a heat pump. The distinction between a refrigerator and a heat pump is one of purpose rather than principle. Refrigerators are cyclic devices, and the working fluids used in the refrigeration cycles are called refrigerants. This is the picture of refrigerator. For the objective of refrigerator is to remove heat QL from the cold medium, and the objective of heat pump is to supply heat QH to a warm medium. There are four components of refrigerator. That is compressor, condenser, expansion valve or throttling device, and evaporator. As we can see in this diagram below, that orange one is compressor and it will flow to the condenser, and then it will flow to the expansion valve, then it will flow to the evaporator. For more details about the components, I will pass to the next presenter.
Assalamualaikum. So one of the important component in refrigerator is compressor. Compressor is the heart of the refrigeration system. The power required for transmitting heat from low temperature space to high temperature space is given here. When refrigerant passes through a compressor, it gets highly compressed, that is pressurized, and its temperature also becomes very low. As it leaves the compressor, refrigerant gets converted into gaseous state. Next, condenser. This heat exchanger is fitted outside the refrigerator, and the refrigerant temperature is higher than atmospheric temperature. So heat will dissipate to the surroundings. The vapor will be condensed to liquid, and the temperature will return to a normal level. Expansion valve or throttling device. The throttling device obstructs the flow of liquid. Cold liquid is produced when with the help of this device. In this case, the throttling device is a capillary tube The capillary tube has an approximate length of 2 meter and an inside diameter of around 0.6 millimeter, so it offers considerable resistance to the flow. Next, I will pass to the next presenter.
Okay, hello. So the next thing is the evaporator. So the evaporator is heat absorption process. The next phase is a simple where this cold liquid is passed over the body that has to be cool. As a result, the refrigerant absorbs the heat during the heat absorption process. The refrigerant further evaporates and transforms into pure vapor. A, a proper heat exchanger is required to carry the cold refrigerant over the body. This heat exchanger is known as an evaporator. So, how refrigerator work? So, firstly, the compressor constrict the refrigerant vapor, rising its temperature and push it into coil on the outside of the refrigerator. Next, when the hot gas in the coil meet the cooler air temperature of the kitchen, it becomes liquid. So the next step will be now in the liquid form at high pressure. The refrigerant cool down as it flow into the coil inside the freezer and the fridge. The refrigerant absorb the heat inside the fridge, cooling down the air. And lastly, the refrigerant evaporate to a gas, then flows back to the compressor where the cycle start all over again. So the basic principle of refrigeration is refrigeration process work on the principle of second law of thermodynamic. The second law of thermodynamic essentially states that if a cold object is placed next to a hot object, the cold object will become warmer and the hot object will become cooler, as the picture shown. So I will pass to the next presenter.
So there is two vapor compression of refrigeration cycle. What first is the ideal vapor compression refrigeration cycle. Second, actual vapor compression refrigeration cycle. So the vapor compression refrigeration cycle is the ideal model for the refrigeration system, air condition and heat pump. It consists of four processes, from 1 to 2, the isotropic compression in a compressor, 2 to 3, constant pressure heat rejection in a condenser, 3 to 4, throttling in an expansion device, and 4 to 1, constant pressure heat absorption in an evaporator. The process in ideal vapor compression refrigeration cycle. So the refrigerant enter the compressor at the state 1 as saturated vapor and is compressed isotropically to the condenser pressure. The temperature of the refrigerant increase during the isentropic compression process to well above the temperature of the surrounding medium. The refrigerant then enter the condenser at superheats vapor at state 2 and leave as saturated liquid at state 3 as a result to the heat rejection to the surrounding. The saturated liquid at state 3 enter an expansion valve or capillary tube and leave at evaporator pressure. The temperature of refrigerant drop below the temperature of the refrigerate space during this stage. The refrigerant enters the evaporator at stage 4 as saturated mixture and it completely evaporates by absorbing the heat from the refrigerate space. The refrigerant leaves the evaporator as saturated vapor and re-enter the compressor, completing the cycle. So I will pass to the next presenter.
Okay, I want to talk about the actual vapor compression refrigeration cycle. Okay, an actual vapor compression refrigeration cycle differs from the ideal one owing mostly to the irreversibilities that occur in various components, mainly due to fluid friction causes pressure drops and heat transfer to or from the surrounding. Okay, the differences is non-isentropic compression, superheated vapor at evaporator exit, next subcool liquid at condenser exit, and lastly pressure drops in condenser and evaporator. Okay, this is the TS diagram for basic vapor compression cycle. Okay, the cycle process can be described as follows. Okay, based on the diagram, 7 to 1 evaporation of the liquefied refrigerant at constant temperature T1 equal to T7. Okay, for 1 to 2, superheating of the vapor from temperature T1 to T2 at constant pressure PL. Okay, for 2, 3, compression not necessarily adiabatic from temperature T2 and pressure PL to temperature T3 and pressure pH. Okay, for 4 to 5, condensation of the vapor at temperature T4 equal to T5 and pressure pH. Okay, for 5 and 6, for 5 and 6, 5 to 6, subcooling of the liquid from T5 to T6 at pressure pH. For 6 to 7, expansion from pressure pH to pressure PL at constant enthalpy. Okay, for the conclusion, special chemicals called refrigerant are used as the substance that enables the process to function. The cycles involve the changes of state and the energy consumption and heat loss associated with these phases changes is the key to the process. The refrigeration cycle has quietly influenced modern society, and without it, our progress would be halted. Thank you.
Okay, that's all from us. Thank
Thank
you,
you.
sir.
Thank you, sir.
Thank
Thank you,
you.
sir. Bye.
Stay safe.